Left to learn. So if you weren't here last night, I didn't realize there were... Did some of you guys just lose that sheet? Or were there that many people absent when I gave that out?
My card's in, my bag is in my card, and my card is in help.
I really need like a storage. Alright. Remember when I was talking about how little I cared? So, I'm not going to get wait till you do this right now, but if you just got that sheet, you should write this down. This is basically the chapter. I wouldn't do it right now, because, I'm going to be going through other stuff, and then you'll miss that stuff. But, before you, leave, that's the chapter. We're basically going to go through all of that today. So, that goes up here. Alright, first thing. It's actually February, and we're just getting to the definition of this class. It's a statistics class. I never even said, what is the statistic? So, samples are the small part. That's like the spoonful of soup that you try. Population is the big part. That's like the pot of soup that is cooked. Population's like the big picture, if you could ask everybody, like a census. But usually we don't want to, or have time, or have enough money to ask everybody, so we take a sample. We try to look at the small picture and use that small picture to make decisions about the big picture. That's what statistics is. So the sample is the part, and numbers that come from the sample are called statistics. That's what this class is. Population is the whole. Numbers that come from the population are called parameters. It's kind of nice that they start with the same letter. So statistics come from the sample. Parameters come from the population. Fair enough? So go through those 5 there, and every number that's underlined, just put a P or S next to it. Is that a parameter, or is that a statistic? Elena is here, right? She just went to the something. No hope. Alright, so I don't think there's anything earth-shattering here. In myelin, and then I take a sample of 100. So the myelin in this case is the population. That's the big picture. So that number is the parameter, and then the 100 I took as a sample. US 45,000, that's the population. I go survey 100 people, that's the sample. Mean weight of females is whatever, that's the population. I call a sample of 50, that's your statistic. 110 are from the population, and then the 120 and the 15 are from the statistic. And that'd be a parameter of the population. Good? That's easy enough, right? Alright, sampling distribution is what we did before. That's that. Remember, like, we had the blue bars come down, and drop it. Like, we'd take 5 bars would come down, and then 1 would go down in the middle. Then take 5 more. And that blue thing at the bottom, when we did that on the computer, that's your sampling distribution. That's if I took every possible sample of size whatever and put them in a distribution. Bias, we've done before. Somebody raise your hand and tell me a type of bias and what it is. See if you remember any of these. See if you guys are weak. What could cause bias? Bias is just like something that's unfair, or like the way you phrase the question, or the way you take your survey causes things to not turn out the way they really should turn out. Yeah?
Police officer asking someone if they've done drugs.
What type of bias is that? Anybody else? Anybody? First of all, is it bias? Yeah, you might not get an honest response, right? What type is that? Response bias. So that's any bias where like the question is worded in a way to lead you things to a certain response, or the person asking it might try to lead you to a certain response. What about, I call 100 people and ask their opinion on whatever, and 35 of them say, screw you, I'm not going to talk to you. What type is that? That's non-response, because they're just not responding. What about, I want to know people's opinion on food stamps, so I go to a homeless shelter and ask them. What type of bias is that? Is it biased? Yeah, because there's a giant proportion of the population that I'm not even asking, right? So I'm not covering that part of the population. Under coverage. Call into my radio show if you want to talk about gun control. What's that? That's voluntary, so what type of opinions are you going to get? Like the really strong ones, one way or the other usually. Which could be like the same proportion of for and against, but it's not representative is the idea. So biased, I think we have an idea of that. We've talked about that for a while. So go through these 4 here. And just, again, this is not earth shattering, it's almost just a review. Tell me if it's biased or not, and if it's biased, tell me what type it is. Biased or unbiased, and if it's biased, tell me what kind. Good to be back. Welcome back. Nice to see you all here. I missed you. Well, like a couple of you. Not you. Actually, none of you. You still have tests? You do, right? That one that you were practicing like at home.
I have questions.
We had that 8-hour study. Either way. You're welcome to come. First one, biased or unbiased? Unbiased. And here's the other idea with biased and unbiased. This is your population. So number 1, like this is all the ACT scores at the school. We start taking a sample of 20 and graph those averages down here. If it's unbiased, what's going to be true about mu and x bar? They're going to be the same. If it's a fairly done sample, these should be the exact same. But if I look at that second one, so I'm going to ask you if you've done drugs. I'm going to do 20 at a time. I'm doing a sampling distribution. But is that biased? It is biased. What type of bias is that? Response bias. Where do you think x bar would be in comparison to mu? Lower, wouldn't it? It's actually proportions. It's a weird, I don't know if that question made any sense. But if I want to find like the true number of people that have tried drugs, but I do it this way, aren't I probably going to get a number that's less? People aren't going to really want to be honest about it. So that's what the bias is. When this distribution doesn't have the same middle as the population does. Number 3, biased or unbiased? Unbiased, that's like as fair as you can get. Number 4, biased or unbiased? That's biased. What type? Response bias. Do you guys even know who Mr. McMahon is? He used to be the principal before Mr. Shin. He's the assistant superintendent now. He got promoted, but I think he was before. You guys never had him. You're a freshman here? Okay. Yeah, what's up?
On the front by bias, it says that if the mean is different than the actual, then it's unbiased.
It says that it's unbiased if it's different? That would be an unfortunate typo. That's the complete opposite. So I didn't even read through that. If the sampling distribution results in a mean that is different than the actual population, the statistic is biased. Thank you for being like the only person that actually reads when I type. This is wrong. Like I just typed unbiased there by mistake, but that's biased. If the means are different, that's like the definition of bias. So I was trying to give you the definition, but I didn't. Thank you. So number 4, would X bar be lower or higher than mu? Lower, right? Like you're not going to, not everyone would admit, so it'd be lower amount. Alright, questions on, so what are we talking about? Population or sample or bias? Okay. Next idea is variability. So variability has to do with how spread out things are. It's basically standard deviation. Here's the easiest way for me to explain this. So if I start flipping coins, on this axis I'm going to put the percent of times that it came out tails. So it could be 0, it could be 100. And then I'm going to mark it after 1 flip, 2 flip, 3 flips, 4 flips. I'm just going to keep track of this as I go. Well, we know what it's supposed to be, right? It's supposed to be there. And over the long run, what will happen? It'll kind of wiggle its way there, right, eventually? But in the beginning, so let's say I flip, I'm not going to do it, but let's say I flip here. I got one. That's heads. So what percent of flips are tails after the first flip? 0. Heads again. Still 0. Tails. So now what percent are tails? 1/3, so like 33%. Heads again. So now we're at 1/4, so 25%. Tails, so now we're at 2/5, so it's like 40%. Every flip at this point in the process has a pretty big effect on the next percentage, doesn't it? After like 1,000 flips, how much impact would the next flip have on the percentage? Like not much at all, right? You might flip from like 49.8% to 49.9%. So in general, this will kind of start off, and I don't know if it'll be up or down, but it'll get closer and closer to the true answer as we move forward, right? In the beginning, this is a high variability because it's possible that we're really far away from like the true answer. So this part is high variability. Every dot has a huge impact because there's just not very many dots. And I don't know, like I could be really far away from what the actual answer is. As I get way out here, you think about if this was like 1,000 flips, this would barely be wiggling. How much impact would every flip have? Not very much. How far away would we be from the true answer? Not very far. This is low variability. Does that make any sense? Okay. Read through those next 5 there. 6 there, I guess. And tell me if they're high or low variability. basically sample size. Like the bigger sample you have, the closer you're going to be to where you should be in terms of low variability. So number one, 5 free throws, high or low variability. That's high, because I could be really far away from like what their true answer is, and every free throw I shoot is going to like dramatically change, or could dramatically change the percentage. Flip a coin 4 times, that's high. I could have 0. I could reasonably get like 0 heads or 100% heads, and that's a huge difference in the possible outcomes. I had 2 people if they like block scheduling. Well, I'm either going to get 0%, 50%, or 100%. That's a huge spread in the possibilities. That's variance, that's variability. I asked 800 students, that's low. So now, like, I'm going to be zeroing in more on what the true answer is. 5 is high, and 6 is low. I'm going to get all 6 of those correct. Okay. So ideally, we want unbiased. So it's in the center. We want low variability. That's what that bottom graph is. This is called the central limit theorem. That's what we talked about last time. And here's that link, because, you know, I'm sure a bunch of you will go to that link and play with the blue bars and stuff. But I wanted to put it on there just in case someone wanted. Question on the sheet. Okay. So we used to do this when I had like block schedule, because classes used to be an hour and a half long. Did you guys ever have that? Like, seniors, you missed block schedule? A year. So I had to give like breaks. So come up, I'm going to resume class at 9:30. Before that, you need to grab one of these packets and do your dice. Second, you're not going to listen to me if I just talk for an hour straight. I'm getting used to myself for a minute.
She talks about them for 2 days and then puts them on this. I was barely starting to it's already said it's just up here and I have to know. It's like not that much time.
She drove you.
She decided to try to say something. I got little kids. I could go outside. Are you serious? That wasn't like the 30 below day. But still, winter and cold. You gotta fix it before that. You ever seen the restaurant?
Yes.
Yeah, you have like it's like 5 times. Really? Entertaining.
Sucks.
There. Do it.
Wait a minute.
I absolutely hate it. Yeah. I was a little worried. But I was, hold on, fine. I felt so bad when
Everybody got a packet? Still asking if you have a packet. I gave a break till 9:30 and she walked up the door at 9:29.
That's why I left it to you, because I knew you'd yell at me.
What's the point? Your time is coming to an end. Okay. Quiet, please. So, again, I left some space at the top. I want to remind you of a couple things. To find percents, use normal CDF. If given percents, what do you use? We're going backwards, inverse norm, right? So, for this chapter, and really for the rest of the year, you got to make two decisions when you read through any problem. Are we dealing with means or are we dealing with proportions, which is basically percents? So did I tell you like the average of this is 7, or did I tell you like 27% of people thought this? So you're going to first decide, this should just be like a huge divider. Am I dealing in means or proportions? Then you're going to decide, am I dealing with the population or am I dealing with the sample? So it's basically going to put you in one of these four. They're either going to be means and population, means and sample. This one you'll never really have to do, or it could be that. So the first time you read through every problem, means or proportions, population or sample. On this page, every problem is a mean. So I'm slowly introducing it. So sample means. So if you're dealing from the population, your mean, well, okay. Your mean is mu, and your standard deviation is sigma. Like that's not anything different than we did before. If you're dealing from the sample, your mean is now called x bar, but it is true that these are the same value. So it's like a vertical equal sign that's supposed to be. Mu and x bar are the same value, but it is important how you write it. X bar means it's from the sample. And your standard deviation, which is now written as the standard deviation of x bar, is the original standard deviation divided by the square root of n. got two options depending on if we're picking from the population or from a sample. So remember with our samples, like the bigger the sample we take, the smaller the standard deviation gets. So the bigger number that's on the bottom of that fraction, that'll make the value of the entire fraction smaller and reduce that standard deviation. Alright, so if I read through number one here, they give me the average ACT score for AP students. So this is like population data. So that's my mean. That's my sigma. Part A, find the probability that a randomly selected student from the population has an ACT score of whatever. So am I dealing with the population or am I dealing with the sample? Dealing with the population. So this is actually a problem I could have given you like in chapter 2. This would be, I want to find the probability, so that's normal CDF, over 26, be 26 and up, so 26 comes to 999. Then you tell the calculator the mean and you label it on your paper, and you tell the calculator the standard deviation and you label it on your paper. And then I'll type it in. I know you can type it, I'll just get an answer so we have something down there. So this is 0.0478. So 5% of the time, if I randomly pick people, I'll get someone that got a 26 or higher. Well, if I start taking 20 students at a time and average their scores together, is it more or less likely that I'll be 26 or higher? It's less, right? Because the more I take, everything sucks back to the middle. So 26 is a pretty high score compared to the mean. Mean's 23.5, but 26 is higher. So as I start taking more samples, everything's going to pull back. So this number here should be smaller. So let's read through it. If I randomly select 20 students, well, right away, what does that tell me? Population or sample? Now I'm dealing with the sample. So I still do normal CDF. I still want to know 26 and higher. But the next two things change. Kind of. What goes here is still 23.5, but what's it labeled now? X bar. Because we're dealing with the sample. So we're in this, we're using these two things now. We're in means and we're in samples, so we're here, we're using these two boxes. And then my standard deviation, which should be labeled as S sub x, is going to be the 1.5 that I had before divided by the square root of 20. So it's like the same format, but you're using different inputs because we're dealing with a sample which narrows down everything. So these are always going to be the same number, just labeled differently. And this will be the same number as it was above divided by the square root of it. All right, so go ahead and type that in. It's probably 0. And you can just put like the square root of 20 right there. Like I never figure out what the square root of 20 is or divide or anything. I just type in 1.5 divided by the square root of 20. So yeah, that's 4.5 times 10 to the negative 14th. Remember what's that mean to do with the decimal place? Move it 14 places to the left, so we're going to have 0.130, so it's basically 0, right? So you can see 0. But don't put that E, because that's not really a number. Which is the higher probability? Part A. And then you get what they want to see here, central limit theorem. Says higher N pulls values towards them, or towards me. Questions on 1. Try 2. So the average height of professional basketball players is approximately normal with a mean of, so that's my mu, 78, and a standard deviation of 2. That's like the big population. That's the big picture. So that's population. Part A says if I randomly select 30 players. So what did I do right then? What did I do? Took a sample. What's the probability? So I'm looking for probability. As soon as I'm looking for probability, what am I using? Normal CDF. So it is normal CDF, but it's from a sample, and I have to keep that in mind. What's the probability that average height is less than 75? So less than 75 would be negative 9999 up to 75. And then what number goes here? 78. But what's it labeled? X bar. What number goes here is not 2, but 2 over the square root of 30. And that is labeled S sub X bar. So that's the standard deviation of our sample is what that's saying. And then let's type that in. Questions on where I'm getting the numbers from? Why'd you put this here? Why'd you do this? Okay. So I literally got 0 this time. It didn't even give me like to the negative whatever. It just straight up told me 0. So could I find one person that's like abnormally tall? Yeah. If I start taking a group of 30 and averaging them together, it's almost impossible. Or this one says it is impossible to have people that are that abnormally tall. Questions on A? All right, B. What is the probability? What's that tell me right away? Normal CDF. But a randomly selected person. So if I'm selecting one person, where am I selecting that one person from? That's a population. So if you're just taking one person, it's really the population that you're using. Or, if you really want to think about it as a sample, if I'm taking one person, what's N? 1. So if I divide by the square root of 1, wouldn't I still have sigma? So I still have the same value. So like you could really think about it as a sample of 1 and just divide by the square root of 1. Or you could think about it as it's from the population. It won't really make a difference. But to me, I read that as, okay, I'm taking one person from the giant population, so I'm going to use population shorter than 75, so negative 999, comma 75, comma 78, and I'm going to label it as mu, comma 2, and I'm going to label it as standard deviation. If you put 78 and X bar there, and then 2 divided by the square root of 1 here, that works too. It's not going to come out different math-wise. So that one I got 0.067. Anybody agree? Questions on 1 or 2 or what I'm doing there? Try 3. Same idea. You guys getting these two numbers? Yes, no? So if you're not, here's what I wrote out. Let me know if I can help explain them. So the first one's from the population. It's one person, so I'm picking that one out of the giant group. So I'm just using the 100 and the 15 they gave me. The second one's a sample of 3, so now I have to divide by standard deviation by the square root. Questions there? Alright, flip it over. I didn't really do a good job here of describing. So for number 1, we're taking a sample of size 80. I didn't write that, but I wrote it in part E. That doesn't really help us in part A. And number 2, we're taking a sample of size 25, which will matter in a second. Okay. So for number 1, 25% of the students here are considered college ready. So that's the population. 1,000 students here, which is not even 1,000 anymore, but 25% of the students. So your mean, or your P, is 0.25. So I wrote decimal up there because people are never sure, like, should I use 25%? Should I use, like, 250? Because that's 25% of 1,000. But your mean is going to be the percent turned into a decimal. So the mean of the standard of the sampling distribution is 0.25. What is the standard deviation? Well, so I'm looking over there in samples and I'm in proportions. So again, you got to decide 2 things. I have proportions, so I'm here, and I'm taking a sample, so I'm here. So this is my mean. This is my standard deviation. So P is 0.25. So you're going square root of 0.25 times 0.75 divided by 80. So I got 0.048. Next part, I'm just realizing now I did not address this on the first page. For means, we're only allowed to, and I think I violated the rule then twice, but we're only allowed to use normal CDF, calculate the standard deviation, do all that stuff if I have more than 30 people in my sample. So I go back to the first page. I don't even think I have more than 30 people in my sample today. So one of them was 3, which is nowhere close to 30. One of them was, but they're okay. I'm not gonna go back and fix it because there's other ways that can be addressed, and I don't want to get into all that. I do want to get into this. You're not allowed to use mean, standard deviation, normal CDF, inverse norm, all of that stuff for proportions, unless both of these things are true. So we'll clean up the means part later, but I want to do the proportions part now. This is like the sample size of proportions. So you have to have these. So if n times p is greater than 10, that means you got greater than or equal. You have enough people in your sample to say, okay, that sample is normal, and I can use normal CDF, I can use inverse norm, I can use all that stuff. If I don't have enough people, when I start dropping those blue bars down, it's still a weird shape, and I can't really do anything with it yet. So that's what I'm saying here. When can I use the standard deviation formula? For that to work, n times p has to be greater than or equal to 10, and n times q has to be greater than or equal to 10. That's what allows you to use standard deviation. That's what allows you to say it's normal. That's what allows you to use normal CDF, inverse norm, all that stuff. So is this one normal? Well, what's n? 80. What's p? 0.25. So that's 1/4, right? What's 1/4 of 80? 20. That's bigger than 10. N times Q then, so N is still 80. If P is 0.25, what's Q? 0.75. So 80 times 0.75, 3/4 of 80 is 60. Bigger than 10, so we're good. So we should be checking that in every single problem. We should have done it with means too, and that's my bad, but we'll fix it later. But we should be checking this in every single problem. So is the sampling distribution normal? Yes, and I know it because of what I just checked. So part B, if the sampling distribution weren't normal, I couldn't even answer. I'm just saying, like, I don't know, it's impossible, can't calculate. This one is normal. So, two things going on. I randomly select 80 students, so what does that tell me? I'm at the sample level. And then what's the probability? What does that tell me? Normal CDF. Normal CDF. What's the probability 30% or more will be college ready? So our mean was 0.25, right? So we got to use decimals for like all the whole calculation. So more than 30% would be 0.30 and up. You're going to tell the calculator the mean, which is 0.25, and that's P hat. So we're labeling these two things. Just like we labeled these two on the last one, we're labeling these two here. And then 0.048 here, which you could put S sub P hat, like that's the standard deviation of P hat. Just like before, we put X bar, the standard deviation of X bar. Let's type it in. So I got 0.15. Yeah.
So they give you a percent, so why don't you use
So they're asking the probability that 30% or more. Inverse norm would say like, find the 30th percentile. Did you see the difference then? Okay. You guys getting 0.15? Yes, no? Okay. Alright, let's look at 2. What is the mean of, so 78% of the students, I like 78% of the students at this school. Interesting. What's the mean? 0.78, so it's the decimal version. Remember, N is 25. What's the standard deviation? Before I even calculate that, am I allowed to calculate a standard deviation in this case? So like off to the side over here, before I even, like, these questions could be in whatever order you want, but these things have to be true for me to proceed with this question. So N is 25, P is 0.78. That is 19.5, that's bigger than 10, great. But what's Q? 0.22. 25 times 0.22 is 5.5. Well, that's a violation. So I can't do that, I can't do that, no, and I can't do that. Like, you get to skip the entire problem with that. So, I mean, that's one reason you should be on the lookout for it, because you save yourself a bunch of work. Okay. Try number 3. I'm talking a long time. I know this is a lot of material. I'm not going to do anything about that. I'm just acknowledging that I know it. I'm aware. So before anyone goes too far down the wrong path here, this is the first thing you should be checking. What's n? 20. What's p? 0.6. 20 times 0.6 is 12. That's fine. But what's q? It's 0.4. Well, that's only 8. It's not greater than or equal to 10, so I can't do the problem. Hello? We're doing nodes. Sure. Yep. Jacob, Mr. Shit would like to see you. So, does that make sense that I couldn't even begin the problem because I don't have the conditions met? We good there? Alright, now what I want you to do is change this 20 to a 40. And actually do the problem. Stay with me. I'm done in 5 or 10 minutes. Again, I know this has been a long time. Appreciate your attention. Alright, so what is the probability? The first thing I realized there is I need to be doing normal CDI. 50% or less, so that's negative 9999 up to, how do I write 50%? 50 or 0.5? 0.5. And I tell the calculator the mean, so that's 0.6, and how do I label that? I'm in percents and proportions, and I'm in a sample. So my label is here. And then the standard deviation is the square root of 0.6 times 0.4 divided by 40. And that is S sub p hat. And then I just type that in. And I just type that in all at once. I'm not figuring this out separately. Like I said, I'm just typing in, making the calculator do the work. So I got 0.098. Anybody agree? Anybody else get that too? Questions? Why'd you put this here? Where'd you get this from? What are you doing? Did Mick get in trouble? Is he in trouble? He could be in trouble. He is in trouble. Alright. Question on 3. Do 4. Try 4. Do 4. Try 4. What? So I got 10,000 people. So with 10,000 people, like your N and D are going to be big enough. 15%, but let's just check them. So 10,000 times 0.15, is that greater than or equal to 10? Well, that would be 1,500. So that's good enough. And then if 15% is bigger than 10, we're pretty sure 85% will be bigger than 10. You're still supposed to show it. Oh, thank you. That's 15. We're still good. And then 85. So we're good. Okay. So then, what is probability? So what does that tell me right away? Normal CDF. And I want to know between 10 and 20%. So I'm going to go 0.1, comma 0.2. I'm going to tell the calculator the mean, which is 0.15. That's b hat. And then I'm going to go, okay, the square root of 0.15. 0.85 over 100, and this is S sub b hat. So you got a couple things to do, because you got to know the, how to do the problem, but then also the notation. So I got 0.838. Anybody agree? How many got that? Questions I can help with? Which part? Does that matter?
Yes.
Okay. Yeah. Okay. So I'm done. You're not though. The next 2 pages, so page 3 and 4, I numbered them this time. Really proud of myself. There's 10 problems on there. That's what I want you to do. So you're working on those 10. I do have the answers up here. I'll even throw them up on the board. But you gotta know how to do stuff. Make sure you check the conditions, because there's a few that you can't even do.